Hello everyone, I'm Hari Tatavarthi, Senior Specialist Architect for Analytics at AWS. In today's digital landscape, real-time notification systems have become crucial for delivering exceptional user experiences. Whether you're building a real estate platform, a job matching service, or a price alert system, the ability to instantly notify users when their criteria are met can be the difference between a good and a great application. Today, I'm excited to talk about OpenSearch Percolators, a powerful feature that transforms how we approach real-time matching scenarios. What makes this particularly interesting is how it inverts the traditional search paradigm to create more efficient and scalable solutions. Before we dive deep, let's understand what percolators are and how they are different from traditional search. A typical workflow for OpenSearch is to store documents as JSON in an index and execute searches to find those documents. Percolation essentially reverses that. You store searches and query with documents. Let's say I'm searching for a house in Chicago that costs less than $500,000. I could go to the website every day and run my query, but a clever website will be able to store my requirements as a query and notify me when something new comes up that matches my requirements. Percolation is an OpenSearch feature that enables the website to store these queries and run documents against them to find new matches. Now let's understand how traditional search works. Traditional search operates on a pull-based mechanism where users must actively initiate each search query to discover matching properties. This approach requires regular manual intervention to stay updated with new listings, potentially creating gaps in property discovery. While effective for point-in-time searches, it places the burden of monitoring on the user, who must repeatedly execute searches to discover new listings. This process can be time-consuming and may result in missed opportunities, particularly in dynamic real estate markets where timing is crucial. In order to better understand how traditional search works, I have put together a sample property listing application. Using this application, the home buyers can set the search criteria for their dream homes, such as location, property type, number of bedrooms, number of bathrooms, and school rating. After setting the search criteria, the home buyers have to perform the search manually to identify properties that match their criteria. Any properties that are listed after the initial search will not be displayed until the home buyer hits the search button again. The percolator approach transforms property searching into an automated, push-based system that continuously monitors new listings against stored user criteria. It's a two-step process. Step 1. You start by registering the search parameters as a query in the percolator index. Step 2. You then run new property listings against these stored queries in real time. This inverted search paradigm ensures immediate notifications when matching properties become available, thereby eliminating the need for manual searching and reducing the risk of missed opportunities. The system effectively serves as an automated monitoring service, providing timely alerts only for properties that match the user's specific criteria, thereby optimizing for both efficiency and effectiveness in the property search process. Now let's see how the same property listing application can generate real-time alerts using OpenSearch Percolators. Behind the scenes, as and when new listings are made available, they are executed against Percolator index. If a match is found, the home buyer is alerted via a push notification. As you can see on the screen, once the alerts are activated, home buyers continuously receive alerts on properties that match the search condition. In a traditional search scenario, this OpenSearch query represents what happens every time a user clicks the search button on the property listing website. Think of it as a snapshot in time. The user specifies they want a single-family home in Chicago between $300,000 and $500,000 with their must-haves like 3+ bedroom, 2+ bathroom, good schools, relatively new construction. And the system immediately searches the underlying index to find matches. However, this is where the limitations become apparent. It's like taking a photo of the available inventory at the exact moment. And if new properties hit the market an hour later, the user won't know unless they manually perform another search. The implementation of percolators in OpenSearch is both elegant and powerful. We begin by creating a specialized percolator index. This isn't just any index. It's specifically designed to store queries rather than documents. The index includes special mappings that incorporate the percolated type field along with fields for metadata like customer IDs, priority levels, and notification emails. The core structure looks like this. First, we define the mappings that include the percolator field type. which is crucial for storing queries. Then, we store user queries in this index, each associated with relevant metadata. The magic happens when new documents arrive. We run them against these stored queries using the Percolate API. What makes this particularly powerful is that OpenSearch optimizes these operations under the hood. It uses its internal data structure to efficiently match incoming documents against thousands or even millions of stored queries simultaneously. This means we can achieve real-time matching without significant performance overhead. When implementing percolators in production environments, scaling considerations become crucial. Based on real-world experiences and AWS best practices, there are several key strategies to ensure optimal performance. First, always maintain separate indices for percolators and documents. This separation allows you to optimize each index independently by tuning shard counts and refresh intervals based on specific usage patterns. Second, implement query filters effectively. By segmenting your queries and using appropriate filters, you can significantly reduce the scope of matching operations, thereby improving overall performance. Third, consider implementing a buffer in your ingestion pipeline. This allows you to batch your operations and manage load more effectively, especially during peak times. The buffer acts as a cushion, helping you maintain consistent performance even under varying load conditions. Finally, for high volume scenarios, consider deploying a dedicated cluster for percolation operations. This separation ensures that your primary search functionality remains responsive while handling intensive percolation workloads. As we have explored today, OpenSearch percolators represent a fundamental shift in how we approach real-time matching and notification systems. By inverting the traditional search paradigm, they enable us to build more responsive, efficient, and scalable applications. Remember, the key to successful implementation lies in understanding both the power and the limitations of percolators and following the best practices that we have discussed. The ability to match new data against thousands of stored queries in real time opens up exciting opportunities for building more dynamic and user-centric applications. Thank you for your attention today. I encourage you to explore percolators in your own applications and experience firsthand how they can transform your real-time matching capabilities.